Welcome friends. Today we are going to discuss the most important 58 interview questions regarding quantum mechanics. So without wasting further time, let's start the video. So question number 1 is, what is quantum mechanics? Answer is, quantum mechanics deals with the particle nature of radiations and wave nature of matter. Matter means particle. It is actually concerned about wave-particle duality, and only fast-moving microparticles are discussed in quantum mechanics. Question number 2 is, what is the difference between classical and quantum mechanics? Answer is, classical mechanics deals with the macroparticles that move very slow speed as compared to the speed of light, whereas quantum mechanics deals with the microparticles that move very high speed comparable to the speed of light. Question number 3 is, what is wave-particle duality? It's a very important question. Answer is, wave-particle duality means both matter and radiation have dual nature. Sometimes they act like a wave and sometimes they act like a particle, but both these behaviors can never be observed in a single experiment. This unique behavior of matter and radiation is called wave-particle duality. Question number 4 is, what is de Broglie hypothesis? Answer is, according to de Broglie hypothesis, particles also have dual nature like radiations, and so particle can move in the form of waves. So whose wavelength is equal to lambda is equal to h over p, yeah, lambda is equal to h over mv. Next question is, what is wave function? Answer is, the wave which is associated with a moving particle is represented by a function called wave function. Next question is, what are the properties of an acceptable wave function? Answer is, wave function must be finite, wave function must be single valued, and wave function and its partial derivatives must be continuous everywhere. These are the properties that must be fulfilled for a wave function to be acceptable. Question number 6 is, why are operators used in quantum mechanics? Answer is, operators have tremendous importance in quantum mechanics because an operator operates on a wave function and produces some eigenvalue. In other words, operators are used to extract information about the system via wave function. Question number 7 is, what is Hilbert space? It is also a very important question. Answer is, Hilbert space has tremendous importance in quantum mechanics because it is as important in quantum mechanics as phase space in classical mechanics. It contains all the possible states of a system. This is why Hilbert space is also called a complete space. Question number 8 is, what is normalization condition? Answer is, the probability for a particle to be found somewhere in space must be unity. Unity means 100%. This condition is called normalization condition. Question number 9 is, what is Hamiltonian operator? Answer is, total energy of a system is represented by a Hamiltonian operator. Total energy means kinetic energy plus potential energy. Question number 10 is, what is the physical significance of wave function? Answer is, although wave function has no direct physical significance because it is a complex quantity, but still, indirectly wave function contains all the information about the system. Question number 11 is, what is observable? Answer is, anything which can be measured is called observable, like position, energy, momentum, etc. What is the difference between photoelectric effect and Compton effect? Answer is, both these phenomena confirm the particle nature of light, but still there is a difference between them. In photoelectric effect, the incident photon transfers all of its energy to the targeted electron, whereas in Compton effect, The incident photon transfers a part of its energy to the targeted electron and scattered with remaining energy. And the next difference is that photoelectric phenomena can be observed with less energetic photon like UV light, but Compton effect phenomena can only be observed with higher energetic photon like X-rays. The next question is, what is the difference between photon and ordinary particle like electron? Answer is, photon can travel with the speed of light, whereas an ordinary particle can never move with the speed of light. And the next difference is that photon has zero rest mass, whereas an ordinary particle has always some rest mass. And the next difference is that momentum of photon is p is equal to h over lambda, whereas momentum of ordinary electron is p is equal to mv. The next question is, which postulate of Bohr's model agrees to quantum mechanics? It's also a very important question. Answer is, second postulate of Bohr's model agrees to quantum mechanics, in which it is suggested that only those stationary orbits are allowed for which the orbital angular momentum is equal to integral multiple of h over 2 pi. The next question is, what is photon quantum theory of light? Answer is, light consists of tiny packets of energy that can never be further subdivided. These packets of energy are the integral part of all electromagnetic radiations. These tiny indivisible packets of energy are called photons. This is called photon theory of light. And the next question is, what is the difference between phase velocity and group velocity? Answer is, phase velocity describes the velocity of a single wave, whereas group velocity describes the velocity of group of waves making up a packet. The next question is, what is the difference between wave number and angular frequency? Answer is, the number of waves per unit time is called angular frequency, whereas the number of waves per unit distance is called wave number. And the next question is, what are the postulates of quantum mechanics? Answer is, operators are associated with each physical observable. And the next one is, wave function is used to obtain all wanted information about the system. And the next one is, wave function and its partial derivatives must be finite, continuous and single valued. And the last one is, the total probability for a particle to be found somewhere in space must be unity. And the next question is, what is correspondence principle? It's also a very important question. Answer is, according to correspondence principle, with the invention of quantum mechanics, classical mechanics can never be completely overlooked. When lambda is equal to 0, then classical mechanics is used to solve the problems instead of quantum mechanics, and in rest of the cases quantum mechanics is used. This principle actually seeks that balance between classical and quantum mechanics. And the question number 20 is, what is parity operator? Answer is, parity operator is a linear and Hermitian operator which is used to change the position coordinates through the origin. एग्जाम्पल देख लो, लेट्स सपोज पैरिटी ऑपरेटर साई फंक्शन पे लगा तो वो साई पॉजिटिव आर है तो उसको लेगा साई नेगेटिव आर में. क्वेश्चन नंबर 21 इज, व्हाट इज द डिफरेंस बिटवीन वेव एंड मैट्रिक्स मैकेनिक्स? आंसर इज, wave mechanics is based on the Schrodinger wave equation, whereas matrix mechanics is based on the Heisenberg and Bohr assumption and theories. Wave mechanics is used to solve single particle problems in quantum mechanics, whereas matrix mechanics is used to explain the atomic structure. The next question is, what is Schrodinger wave equation? Answer is, when a Hamiltonian operator operates on a wave function and then it produces the energy eigenvalue along with the same wave function, then this equation is called Schrodinger wave equation. H psi is equal to E psi. The next question is, what is the physical significance of Schrodinger wave equation? Answer is, Schrodinger wave equation describes the wave behavior of particles in quantum mechanics, and its solution can be used to obtain all the required information about the system. Its importance in quantum mechanics is similar to Newton's second law in classical mechanics because both are used to solve the problems in their respective branches of mechanics. The next question is, what are state vectors? Answer is, state vectors are used to describe the physical state of a system in quantum mechanics by using the elements of Hilbert space. The next question is, what are Dirac notations? Answer is, Dirac introduced two types of notations, gets and bras. Both are used to describe the physical state of system in quantum mechanics. In fact, these notations are meant to describe state vectors. The next question is, what is expectation value? Answer is, expectation value is actually the average value of all the possible values. The next question is, which type of wave is produced when a particle moves inside the box? Answer is, stationary waves are produced when a particle moves inside the box. The next question is, do you know why potential energy is taken zero for a particle in a box? Answer is, because there is only one particle inside the box and there is no other particle in a box, so there is no force acting on the particle, and gravitational force is also ignored in this case. So when there is no force acting on it, we know F is equal to minus du over dr. Du means potential energy. When force is equal to 0, then potential energy will be constant. And so for simplicity, we take potential energy of the particle inside the box 0 instead of constant. This is why potential energy is taken 0. Question number 29 is, what is the difference between Schrodinger and Heisenberg picture? Answer is, in Schrodinger picture, state vectors change with time but operators remain constant. And in Heisenberg picture, operators change with time but state vectors remain constant. And the next question is, what is Schrodinger cat experiment? Answer is, this experiment was carried out to explain the ambiguous and mysterious features of quantum mechanics. This scenario actually represents a hypothetical cat which might be either alive or dead at the same time. Question number 31 is, what is uncertainty principle? Answer is, according to uncertainty principle, position and momentum of a particle can never be measured simultaneously with 100% accuracy. This is called uncertainty principle. The next question is, tell us why position and momentum of a particle cannot be measured simultaneously. Answer is, because the position and momentum operators do not commute with each other. Note, it is a principle that if the operators of two physical quantities commute with each other, then those quantities can be measured simultaneously. And similarly, if operators do not commute with each other, then those quantities can never be measured simultaneously. The next question is, what is tunneling phenomena in quantum mechanics? It's a very important question. Answer is, when the energy of the incident particle is less than the height of the potential barrier, but still there is a probability for a particle to cross the barrier. This unique phenomena is called tunneling. The next question number 34 is, what is potential barrier? Answer is, it is actually the barrier of potential energy caused by certain forces acting on the particle. Question number 35 is, what is the difference between classical and quantum theory of harmonic oscillator? Answer is, in classical mechanics, energy of oscillator increases or decreases continuously, whereas in quantum mechanics, energy of the oscillator increases or decreases in a discrete way. The other difference is that the ground state energy in a classical harmonic oscillator can be zero, but the ground state energy in quantum harmonic oscillator is not zero, rather it is equal to half h cut omega. The next question is, what is ladder operator? Answer is, ladder operator is used to push a particle one step either upward or downward. During each step there must be a variation in the energy of the particle which is equal to h cut omega. The next question is, what is isotropic and anisotropic oscillator? The answer is, if the oscillator vibrates with the same frequency in all three directions xyz, then such an oscillator is called isotropic oscillator. And if the oscillator vibrates with different frequencies in all three directions, then such an oscillator is called anisotropic oscillator. Question number 38 is, write time dependent and time independent Schrodinger wave equation on the board. ये बहुत दफा क्वेश्चन पूछा गया है, तो ये तो आपको पता है कि पावर पॉइंट पे क्या कहते हैं फार्मूलाज लिखना पूरी इक्वेशन में बहुत मुश्किल है, तो मैंने आसानी के लिए ये किया है, तो आप इसको समझ लो। ये मैंने पेज पे लिख लिया, आप इसको देख लो। टाइम इंडिपेंडेंट स्क्रीनिंग वेव इक्वेशन की ये है और टाइम डिपेंडेंट के लिए ये है, ठीक है। तो ये जो ब्रैकेट में लिखा रहा है ये एक्स है, मतलब पोजीशन, ठीक है। और यहाँ एक्स और टी ये पोजीशन और टाइम पर डिपेंड करता है इसका वेव फंक्शन, और ये वेव फंक्शन किस बराबर होता है, ये इसके बराबर, ठीक है। तो ये आप याद कर लेना लाजमी। द नेक्स्ट क्वेश्चन इज, व्हाट इज कोल्ड एमिशन? आंसर इज, the emission of electrons from metal surface when external electric field is applied is called cold emission. The next question is, what is the difference between distinguishable and indistinguishable particles? Answer is, the particles whose wave functions do not overlap with one another and so they can easily be distinguished. Such particles are called distinguishable particles. On the other hand, the particles whose wave functions overlap with each other and so they cannot be distinguished, such particles are called indistinguishable particles. और एक और चीज याद रखना, distinguishable particles are discussed in classical mechanics, whereas indistinguishable particles are discussed in quantum mechanics. Number 41 is, what is the difference between Zeeman and Stark effect? Answer is, the splitting of spectral lines in the presence of magnetic field is called Zeeman effect. The splitting of spectral lines in the presence of electric field is called Stark effect. The next question is, what is principal quantum number? Answer is, principal quantum number confirms that electrons can have only discrete energy in an atom. In fact, it is concerned about the quantization of energy of an atom. Is, what is Auger effect? Answer is, when an excited electron of an atom comes back to the ground state, then emitting X-ray strikes the outer electron of the atom. Due to this collision, an electron comes out of the atom instead of X-rays. This is called Auger effect. This is actually an internal photoelectric effect. The next question is, what are approximation methods? Answer is, approximation methods are perturbation theory, variational method, and WKB approximation method. These principles are used in those cases when Schrodinger wave equation fails to provide the required solution of certain problems in quantum mechanics. The next question is, what is free particle? Answer is, the particle which has just kinetic energy and no potential energy is associated with it is called free particle. Question is, what is Stern-Gerlach experiment? Answer is, Stern-Gerlach experiment confirms the space quantization. It actually confirms that each electron has just two spins, up spin and down spin. The next question is, what is boson condensation? It is a very important question. Answer is, bosons are those particles which don't obey Pauli exclusion principle, and consequently more than one boson can have the same quantum state. Unlike fermions, bosons tend to accumulate in the same state, more likely the ground state. This is called boson condensation. The next question is, what is Pauli exclusion principle? Answer is, no two electrons in an atom can have all the quantum numbers same. In other words, it means that no two electrons can exist in the same quantum state. This is called Pauli exclusion principle. Question number 49 is, what is the difference between composite and elementary particles, fermion and bosons? Note, all these questions have already been discussed in the nuclear physics video. The link of this video is given in the description, so you are requested to see that video to get the answer of these questions. The next question is, according to Einstein, how is force of gravity produced? Answer is, according to Einstein, force of gravity is produced due to bending of space-time around a massive object. Due to this bending, small objects get trapped in this bending curve. This is how force of gravity is produced. The next question is, what are the two postulates of Einstein's special theory of relativity? Answer is, the laws of physics are same in all inertial frames of reference. The next one is, the speed of light in free space always remains same in all inertial frames of reference. The next question is, what is perturbation and perturbation theory? Answer is, the sudden change in a system by any external means is called perturbation. Due to perturbation, the wave function and energy of the system will change. Perturbation theory is actually an approximation method which is used when there is a small change in a system because of perturbation. The next question is, what is variational principle? Answer is, variational principle is an approximation method which is used to calculate the ground state energy of a mechanical system without solving complicated Schrodinger wave equation. The next question is, what is WKB approximation method? Answer is, WKB approximation method is an approximation method which is used in those cases when the change in potential of a system with respect to distance is small enough to be neglected. That is why WKB approximation method is also called semi-classical approximation. The next question is, what is Dirac equation? Answer is, Dirac is a relativistic wave equation which is used in those problems in which particles move with the speed approaching to the speed of light. This equation was introduced to rectify the shortcomings found in Kelvin-Gordon equation. Question number 56 is, what is Hund's rule? Answer is, the electrons in the subshells remain unpaired as long as it is possible for them. This principle is called Hund's rule. The next question is, what is pair production? Answer is, it is a process in which a higher energetic photon strikes with the nucleus and then it is converted into electron-positron pair. This phenomena is called pair production. And the last question of quantum mechanics series is, what is the physical significance of E is equal to mc square? Answer is, both mass and energy can be converted into each other. In fact, mass and energy are the different aspects of the same thing. This phenomena can be observed in pair production, nucleus, and etc. Okay guys, goodbye.